All right, guys. So thanks for coming on a Sunday afternoon. My name is Ian Johnson, and I'm happy to talk to you about D3 today. First, I would like to thank Christina for organizing this and convincing me to come out and talk and putting all this together. So thank you. It's awesome. Okay, so what I want to talk about this afternoon is some of my adventures in using D3.js. I call it adventures partly because it can be challenging to learn, but like most journeys, it's worth it. The process is fun when you get into it, and yeah, it's a powerful library. So hopefully, I can sort of highlight the many different aspects of it for you, because as I understand, not everyone or most people haven't actually played with it yet. You're all familiar with JavaScript from the survey responses that I saw so far, but not many have played with D3. So it's a big library. I mean, there's a lot of pieces to it, and they're not all interconnected. So you might be able to pull from one part that you want in your web app, or if you want to make just a little data viz, you might use a different part. So let's look at that. A lot of you have already filled out this survey. We will hopefully play with the data at the end, do a little bit of live coding, and explore some of the D3 API. So a little bit about me. I'm Angelot on Twitter, where I tweet a lot, mostly about D3 and data viz kind of stuff. I make some tutorial videos using Tributary. So Tributary is an open source IDE kind of that I've been developing with a couple friends. And has anyone seen the Brett Victor Inventing on Principle video?
Amazing.
Yeah. So this is greatly inspired by that. You have some JavaScript over here on the right. By default, you get SVG over here on the left. If you click on any number, a slider pulls up. You change that number, it changes the code. If you type, it also changes, reevaluates immediately. You change any of the colors, you get a color picker. And so this, makes it, this is really nice for prototyping in D3, since so much of what you're doing is trying to get something to look a certain way. And the less you have to guess at how it's going to look, the quicker you can work, and the quicker you can explore and find something that you like. Yes, I want to leave this page. So I do data visualization with D3. In Tributary, anytime you save your whatever you made, it posts to a GitHub gist. So you can, it's associated with your GitHub account if you log in. And anything you make gets saved in this list. Right now I'm making like my user page with Tributary as with D3 actually. It's still a prototype. But these are kind of examples of stuff I'm building with D3. A lot of prototypes that end up working their way into either the product I'm working on or into some data visualization projects I'm doing. So one of those projects is that I did recently. I co-organized the D3 meetup in San Francisco, and we recently hit 1,024 members, which you will note is a power of 2. So in the bottom right there, I do have the binary representation, and each of these is a person. You can actually click on their member. There's Michael sitting right over there. He joined pretty early on in the process, and over time, as I scroll down, this is just happening over time. You see what the date is on the right there, and this was all made in D3. I'm using cross filter, and this is HTML actually, and there's not really any SVG going on. And you get to the very bottom, and we have that nice binary 1024, right? Also, just for fun, I was playing with force layouts, so you can see which of these people went to these events. And so that's using a D3 force layout to do that. So this is this was to celebrate, I showed this at our meetup, and it took maybe a couple evenings with, one or two other friends, bouncing back and forth, prototyping. We prototyped both the bar chart and the force layout separately in Tributary, and yeah, it's nice to be able to do that pretty quickly because of how expressive D3 is. Yeah, I opened all the examples I would click on just so we don't have to wait for them to load the Wi-Fi. So I'm developing Tributary. Tributary is a web application, so it runs in the browser. It's built in JavaScript and HTML. And since Tributary is for prototyping JavaScript, HTML, SVG things, I can develop Tributary in Tributary. And I like this kind of meta thing. One feature I'm working on is, so this over here is a code mirror instance. You have different tabs, each one editing a different file. And here I've set up in this code mirror instance, I wrote the code to make a new code mirror instance. And what I added here is that anytime you have a console log, it will actually show you what the output of that is. So if I do x plus 5, it'll say 10 right there instead. Or if I do 4, 10, and all these say the same thing, but if instead of that I do, you see it's counting up, right? So I'm looking forward to being able to switch this on so that as you're typing, I hate having to, open the console and then write console log in my code, see what happens here, and then go back, right? You just wanted immediate feedback.
Fantastic. How are you going to handle like infinite loops and stuff like that?
They break. So that is something that I have. It's part of the philosophy of Tributary, and actually something I want to get into and like I want to devote a whole talk to. But a lot of the idea with Tributary is I make certain assumptions about how you use it. So I'm assuming you're going to do small chunks of code, prototypes, and it's kind of skewed towards data visualization. So there's things that make it easier to get your data in rather than maybe play with CSS transforms. But yeah, if you use it quote unquote right, or if you use it within the bounds of these assumptions, it should make you better. Like it should augment your experience. If you run up against those bounds, then it just won't work, and we'll have to switch back to Vim or Sublime Text and use our traditional tools. What I'm hoping though is that by making Tributary is an open source project, it's a library. People will create their own environments in order to build around what their workflow is. So it's actually about building tools for yourself to enable yourself to work faster and more efficiently. So yeah, I mean the crazy thing about it really is all the code over here. Every time I type if I hit enter, it just deleted all the DOM elements in the left side here, and re-executed that, re-evaled. Eval is evil, right? It evals the right-hand side and does it before you can see it. Our computers are so fast now, we can just ignore computer science and build tools that help us as humans, not machines. All right, so yeah, that's some of the stuff I'm thinking about, and
What would you say the main difference between like Tributary with other like JS Fiddle,
right?
All the CodePen and all those.
The main difference is that I made it so I can change it how I feel, but in that spirit, I'm tending towards domain specific. So the ability to make it tailored to what I do. So CodePen and JS Fiddle are general purpose code snippet, sharing, and they're great, fantastic tools. I still use them sometimes as well. But because Tributary is tailored to my workflow, I work faster with Tributary than I can with Vim. And I'm like a 10-year Vim user, and I don't even turn there's Vim key bindings on in Tributary. So even without my Vim key bindings, which any Vim person will tell you, like you have to have, I move faster in a tool that's suited to me. So I'm not saying, actually, I'm not here to sell you guys Tributary or to say you should use it. What I am trying to say, though, is if you can build tools for yourself, where you acknowledge the things that are tedious and what I really needed was not a way to share code, which incidentally has been really great. What I needed was a way to say, how does, like, I just read about this SVG feature. I wonder if I can do X with it, right? And every time I had to do that, I had to make a new index HTML. I had to load d3.js from either the latest GitHub or copy the file from my machine, and I had to write boilerplate, and I had to do at least 30 seconds worth of stuff, right? Probably a couple minutes, but even 30 seconds for me to have an idea, to like all that work that's not getting my idea onto the screen is time that's like killing that idea. And so now I just open a new tab and I just start typing, and my idea, like all the stuff that I need for these type of ideas is there for me. So you all might be doing very different things than I. I encourage you to think about what those things are, and what is it that if you had it would make it so that you could try 100 ideas in the same time that it would take you to do 5, right? I can like help people on the mailing list, or whenever someone's like, oh, why does the color scale not work, I just try it real fast instead of having to think about. I don't even think about the API. I just like write it out, and then I console log the error and debug it. So yeah, it's all about speed. And it just so happens that by sharing it on GitHub or on Gists, I can then prototype something and send it to a friend who will then play with the ideas on top of that and send it back to me, and that's really great. And I'm happy that there's more and more tools that let us work together like that. So I hope that answers the question. So D3.js. This is how I see D3. A lot of tools. They're not all the same one. They're all used for different purposes. You can interconnect some of them. You can use some together. But if you're going to do some tasks, sometimes you only need a few of these, and you put them in the toolbox and go. These are the sort of raw materials that we work with when we use the D3 set of tools. A lot of the examples that you'll see on the website, a lot of the really exciting stuff going on is in SVG because of its power as a vector format and everything that carries with it. It's also recently, partly because of D3, become much more performant and widely supported by the browsers. So we're seeing really interesting things you can do with that. Of course, we're all familiar with CSS and HTML. D3 stands for data-driven documents, so it is about manipulating the DOM, which we're all familiar with doing through jQuery. I don't use jQuery anymore, mostly because all I used jQuery for was to select elements, change an attribute, or change the class, and D3 has the same selector stuff built in, so it just so happens that that tool belt has the things that I need. But it's perfectly acceptable to keep using jQuery and use all the nice plugins, jQuery UI, jQuery Mobile, and you can just pull the functions that you want from D3. Another thing that I, see as a first-class citizen is JSON. When working in D3, when working in JavaScript, both in Node or on the browser, being able to play with the data in the same format you're going to produce with it is invaluable. So you can explore and you can slice and dice and aggregate. I highly encourage people to build REST APIs if your backend's in anything from PHP to Ruby on Rails. Provide your data as JSON so that you can start playing with it in the same tools that you're going to make something with it. Of course, JavaScript is D3 is written in JavaScript, but it's since you're all familiar with JavaScript, I don't need to go into it as much. But when I've taught some workshops in San Francisco and on the mailing list, a lot of people get confused as to what D3 is and isn't. And you do need a solid foundation in certain JavaScript concepts to really make use of D3, especially callbacks and closures are heavily used. And of course, Canvas. People have been drawing really cool stuff in Canvas for a while now, and you can use D3 functions on Canvas as well, not the DOM related ones, or there's actually ways to mix, layer those. But there's a whole suite of D3's API functions which will help you save time just as quickly as with SVG as Canvas, or Canvas as SVG. So I also want to say a few words about data visualization. I think many of you are probably interested in this or getting into it from your fields, or are already just stoked about it or care a lot about it. The way I see data visualization, kind of in the path that I took to get here, it's about communicating with people, right? So you have now this newfound resource that can give you insights, that can let you make decisions, but we can't just read it, like we read English. So we need we need this mode of communication where we combine the data with visualization, and I'd also argue interaction as a way, like this new way of communicating our ideas and convincing people of things and helping us make decisions. So I want to quickly go through several ways that D3 touches these different aspects of this way of communicating, and I've color-coded them to kind of tie it together. So, the first thing you need in a data visualization is data. Without data, no visualization. Well, you can draw stuff, but it's not a data visualization, and you'd be surprised at how hard this is to make some clients understand if you're a data viz consultant or freelancer. So I've got here actually sort of I pulled out all of the higher level D3 API functions, or the classes of them, and I plotted them as a tree map. And this is fake data, but well, here's all the API functions by type, but then I just gave them my own value in terms of how I see their importance. And I actually didn't finish doing that because I was going to spend some time doing that with in front of you guys, with you guys, so we could kind of talk about these different tools and when they might be important to you. But the important thing in this, what I was saying in the context of data, is that you have some JSON here, and then we can turn it into a visual representation to communicate. So I'm not going to close this one. We'll come back to this after we go through a few more of these and talk about that. Oh, actually, and so layouts, I do want to mention this. Layouts are a whole section of the API that the tree map is one of them, but it's important to note that layouts are not actually visualizations. They are a data transformation. So you kind of take some data, like I took this list of objects, and you put it through the tree map layout, and it calculates a bunch of stuff and adds stuff in there. Excuse me, I think I'm not console logging out the output of that, but it adds a bunch of like x, y, dx, dy attributes that will help you create a visual representation, but are not necessarily, like, it doesn't draw anything. So I do want to point that out, because this is an easy thing to overlook when you're getting started with D3 and you see the layouts and you think, oh, pie layout, tree map layout, this is going to draw me a chart. It's actually a data transformation, so that the name is a little bit unclear, I think. But it's very, very helpful, because if you can get your data into one of these layout formats, there are many types of visualizations that become instantly available to you through the examples people share or through existing modules. And one of these, for instance, this is the D3 source code laid out in a radial tree format. Could just as well be laid out in a regular horizontal one. If I refresh this, hopefully it won't load too slowly, but you can see that it's also got these transitions. So this is version 1. Then in version 2, all those functions were added. The transition in version 3, it should switch to in a second. A lot of work done in the geo area. So you can get these nice interactions and effects from somewhere else or someone else's hard work with your data, as long as your data is in the right shape. So I think it's important to be aware of that, so that as you start to play with this, you know you're not starting from scratch. So in visualization, SVG is something that maybe some of you guys are getting into, and with D3 making it much more accessible, it's gotten a lot of love. But it's a declarative vector format, so it's just like HTML is tags, but instead of div, you say rect or circle, and you give it some attributes. Instead of like top and left, you say X and Y, and it draws rectangles and circles, and you can style it with CSS, like strokes and fill or background, that kind of stuff. It doesn't overlap exactly with the CSS properties that you can style, and it's its own spec, but it is very similar in the end. There's things though that you want to do, like draw lines. Like drawing a line in HTML, in pure HTML or CSS, is not just not supported out of the box. It is in SVG, but the way that looks is not. You don't want to do that by hand. So D3 provides some generators. So an example of that would be this. So here I'm drawing some circles and lines and rectangles and transitioning all of these. And if we look at, I was going to start that over, isn't it? Let's just inspect the element for one of these lines and see what that looks like. So this D attribute is the path. So you don't want to be writing this stuff out by hand. And this is where D3, one of the first tools in the D3 toolbox comes in really handy, is the D3 SVG line function. And so that will basically create this path string out of data that looks, well, the syntax is much more accessible when you do it that way. Like this is the line function. You define an X callback and a Y callback, and so if your data has points in it, like in this case I have D.C and D.S, you might normally have D.X and D.Y. So if you have a bunch of XY objects, points, it will draw a line between there. Close this. So, SVG does have some limitations though. It is DOM elements, so once you reach a couple thousand or go further than that, you start pushing against the limits of the rendering in the browser, and as well as just JavaScript interacting with that many DOM elements can be slow. So sometimes you want a lot of detail, and then you want to use Canvas. So here I'm showing an example of another project from Michael and Paul over there, where they've got weather station data from all over the world and coloring by heat, and this is all, it's all data driven, so all like the shapes come from Voronoi tessellation, right? So that's another D3 tool, and that generates a layout, like it's all still data, but then using that data you can draw onto Canvas, and many of the other tools, scales, which I'll talk about later as well, in order to create these details and draw. I think you said it's like a couple of thousand points, right? Weather stations, right?
Yeah, 2100.
2100. And you also said that in this case you were able to make it work in SVG, eventually through optimizing it, right? But if you were to push beyond this, you run into some things, and Canvas becomes a really nice option. So it's good to know that you can do both.
What is the browser support when it comes to SVG and Canvas when you use D3?
So using D3 is independent of those. So just browser support for Canvas and SVG. I'm not sure what Canvas goes back to. I think it's 8 or 7 or something. SVG is 9, I think IE 9, and all other modern browsers. So if you need to support back to 8, you can still use a library called Raphael, and there's ways to mix that with D3, because like I'm saying, there's just pieces, certain tools like the color scales to generate these, it's just these 3 lines of code to create this color scale to map, and if we change any of these colors, we'll instantly see, some different color here. So this, you can use with Canvas, you can use with, these 3 lines of code have 0 browser support. They work in any browser, right? It's when you start interacting with browser features that are not supported. So that, that's the other thing to keep in mind. D3 doesn't do anything limiting cross browsers. It's just that if SVG is not in your browser, you cannot use D3 to manipulate SVG.
The feature with Voronoi and tessellation type features, are those from like 3.js or some other 3D packages, or it's only internal?
That's part of D3.
Yes.
It's one of those layouts, I think. Or just helpers. I think that's what you're talking about with tools. It's just one of those tools.
There's a geom. So D3's namespace, like so each of the like D3.geom, D3.geo, D3.
Is it OpenGL rendering, or is it just?
No, it's just straight. It's essentially just helping you calculate those little shapes. Everything else is just straight drawing paths.
What it gives you is an array of points.
Okay.
So you get an array, and then you can either use D3 and map that array to DOM elements, or use Canvas. You can iterate over them in a for loop and draw what they are. You can use it with Three.js though. You could generate that and then render, iterate over it and create Three.js shapes using that API. So yeah, you can totally play between these.
Yeah, and that Canvas is limited to 2D still, right?
Canvas, no, so Canvas is 2D, the Canvas API is 2D, but WebGL stuff renders in a Canvas element.
So there's anything on D3 layer on top of WebGL?
No, so D3, yeah, that's kind of what I'm saying. D3 doesn't really layer on top of anything. It just allows you to manipulate things, and then you use those to like be represented in one of those technologies. So you can totally generate an array of points and then render them in WebGL, like send them to a shader or, make cubes out of them or something. D3 doesn't care. It's just, it seems more closely tied with SVG and HTML because that's where the DOM is. So you can it will actually store the data on the DOM elements and allow you to, it does a lot of, that's why this selections square is so big. That's where most of the magic happens in D3. It's also the hardest part to learn. It took me at least 6 months to internalize and be able to do it, the same way, like make it work every time. And that is focused more around SVG and HTML. But scales work with any browser, any rendering technology. Layouts, same thing. Transitions are closely tied to selections, so they're not as much. Ajax just replaces a lot of the jQuery stuff and gives you more nicer data. Math and arrays, you're probably familiar with _JS. There's similar functionality in those. Color and string manipulation could be used with anything. Geo can be used with anything. It also just generates data that you then render with Canvas or SVG or WebGL. And geom as well. Behavior are actually components that I can show you an example of later, and they generate SVG right now by default. And then these are sort of internal things that I don't even know how they work. Alright, so as I'm saying, we can make HTML and CSS. This little sketch I did is ASCII art. You can actually put any Twitter image URL here. You can put any image here, but you probably want to do something that's like 72 by 72 pixels because you do more, it creates a lot. And I'm using Chinese characters for the ASCII, so it's obviously not ASCII, it's like UTF-8 art because they're square and it's nice. And so this code actually loads the image into Canvas. Does have to use coarse proxy, cross origin resource sharing, and then it pulls the pixels out, like the color values out of the canvas into a big array, and then I use D3 on that array with the scales, and I bind so that if we were to inspect each of these, you can see as my viewport shrinks, each of these is like a P element with a style, and that, so we could actually class them. We could also like copy paste this somewhere, and you know, it wouldn't format properly. But yeah, so this is just an example of that you can do HTML, CSS, and it was something kind of fun. Interaction is something that I think many of you are already appreciate, building interactive web applications, websites with, you know, I think is a key part of making use of the computer, and we're not just broadcasting anymore. We're not just telling people, you know, TV commercials. We can actually let people explore and tell us things and interact with us. So, part of this is in the context of data visualization. I think this is very important. A lot of the work to date in data viz has been about print graphics and getting things to fit within a two-dimensional space, and I think interaction allows us to explore many more dimensions. An example of this that I like is, you have a bar chart or several bar charts kind of laid out, but you might want a stacked bar chart. Using D3 to transition between these two things is like a couple lines of code. Because I have the data in one format, both of these charts, I don't do anything to data to do these charts. I just, I use that selection magic with the transitions to reposition them based on what I want to do. So this, the point here is that D3 allows you to create this kind of interaction a lot easier than if you were to think through and just do it in your for loops and ifs and else's. So because we can do it easier, we can do more of it, and we can find new ways to allow people to understand things. Linking is a key concept. This is something someone showed at our meetup recently, and I thought was extremely impressive. Here's a case where you have, our data represented, it fits in our 2D space. We can see this was about progressive politics positively correlated with population density. That's sort of the hypothesis, and then you plot it out with population density going to the right and percent democratic indicating progressive politics to the left. And then you can, the cool thing though is that you can see it over here. You see, the top right is more democratic, more dense, and okay, maybe it supports our thing. But where is that, and you can see kind of the darker blue in some of these areas. But if you link these two,
Wow.
You can start to explore these patterns in new ways. You can see, who is this over here? High dense, very Republican, right? Although it would be nice if there was also tooltips, another great interactive thing. Or up here, not dense. Or, what's this band here? Oh, it's all over the country. This is the Midwest. So, so this kind of thing, this guy was able to do this brushing, like what I'm doing now, where it's selecting stuff, is one of the D3 behaviors, a component available to you. The mapping stuff and drawing circles is all well understood examples, and by combining those three things, we get an experience that would have been a daunting task before, but now you can see this and you can start throwing these things together. So it's really great. Also interaction, incredibly, I'm sure all of you do this every day at your job. Those of you that are doing web development, which I heard several of you are, you make it so that when people click on stuff in the DOM, something happens. Your HTML or your CSS change. So I code stalked Christina and found a great example from her. And here she generated this user input. This is,
Yelp data.
huh?
It's from Yelp data.
Yelp data, okay. Yeah, so, and this is an HTML select, so it's generating HTML stuff. When you click on it, it affects the visualization. Asian fusion people usually eat in the evening.
Okay, so can you pull up the code this time? See, I found a problem with their data. Turn, let's see, line. There's a fix variable. No, it should be in the top. About line 17. All right, never mind. Well, don't look. Okay, so the days of week were off in their data, in their Yelp data that they provided for this contest. And so if the days of week seem right, it's because it needs to be moved forward one. So just so you know.
Cool.
Go ahead.
But yeah, so what? Yeah, the point I am trying to make though is that this is great. You know, like this is not many lines of code to get this great interactive thing. You can just really start comparing things, and so this isn't just about creating fancy, you know, SVG stuff. It's you can use the same tools to make fancy SVG stuff and combine it with the input methods that people are used to using in the medium that you're used to creating. Most people get counseling early in the week, not late in the week, huh? But day spas in the weekend. Yeah, food trucks. So yeah, I think that's great. Sort of close these out. One thing that interaction really, you know, and since we're using JavaScript and programming in general lets us do is explore time in a new way, or maybe it's not a new way, but I find that I have much more control over time and can start exploring it to communicate things. So this is actually a visualization of inlets being created in tributaries. An inlet is whenever you click save and it saves to a gist. And I don't know if you can see it down here. This is meant for a bigger screen, I guess. But now, you know, as we want to look through time, we don't have to just plot one graph. You know, someone can just click a slider and find, you know, what happened here or what happened here. And these are actually when Michael used tributary in his class and made all his students use it. So free user testing, that was great. Didn't even crash. So, but yeah. So you can play with this. So this was you know, also made in not very long time, and oh wow, it just past 2,000. Nice. Yeah, and D3 made this easy. I don't know how many lines of code this is, but it's getting towards a lot, like 400. But so another thing that you can show similar to time is things that happen in order. So they happen in time, but it's not actually about what time they happened. And if that's not a confusing way to put it, then this, how many of you are familiar with bitwise operations like bit shifting, or saw it in school and forgot, which is what I did. So this kind of shows, if we start with this number, and this is any number, I can like make it bigger, smaller. This is the binary representation up here. So there's ones and zeros, and when you bit shift, which you cannot see here, oh yeah, here we go. So if I shift one bit to the right, this means go right, I moved everything here to the right one. Oh, I need to fix that part. So as I go forward, you can see that second thing, everything's moving right to the right, until there's nothing left. And same with the left shift, I'm moving, so as I move this forward, I shift left, that bottom one is moving left, right? So I can start to play with visualizing algorithms, which is I'm interested in because I'm trying to understand algorithms a lot. But this is a process, right? Or this is something that, you know, when you read it in the book, this kind of stuff never was clear to me when I read it. I had to do it a bunch of times and see it happen. And so now I can just watch it happen by playing with a slider. And this is all made in D3 and linked up to this slider. So I'm really excited about being able to make stuff like this really quickly. start I also happen to like trying to explain difficult things to people, so it helps. Yeah. And then finally, another thing that I feel like I'm at the edge of, and I don't really know what I'm doing here, but I hope more people start playing with it as it becomes easier. And that is simulation, so letting the computer start to do things that we don't just tell it what to do in a recipe, but we set up some rules and the system just works, follows those rules and things happen. And I'm not quite clear on how to use that to communicate data visually, but I have started playing with it to some nice effect. So here is a flocking simulation that little circles follow my mouse, and then as they get closer, like I'm also doing a Voronoi around them, and then if I just click, nice little effect. So they're just going their own way. I'm not controlling them, but I'm using D3 Voronoi. That the flocking algorithm was actually written as an example someone made for D3, but you can get them from any language or any place. And yeah, with the mouse interaction, this is all SVG elements. You can play with this. So maybe someone here has a cool idea how to actually make this useful. I just kind of stare at it sometimes. I'll stop that and move on with the talk. Yeah, so this can be a little overwhelming. I like to bring up this concept of first principles, which one of my heroes, Richard Feynman, talked about a lot. And so when we have all these new tools available to us, several web standards. I mean, we just named SVG, HTML, CSS, and JavaScript, and WebGL. That's way too much to learn at once. When you're trying to do something, what I'm finding is if I can break it down to the first principles, if I can break it down to just writing just that SVG rectangle by itself, by hand, like, who knows what D3 is doing? Could be doing some crazy magic under the hood. If you can prove to yourself that you can draw one rectangle, and you copy paste that rectangle and draw a second one, then you can draw two rectangles. Now make D3 draw two rectangles. Does it look the same? That's sort of an important tenet of science, and I think we can apply it while we're learning about all these rich web standards. So there are some resources to maybe help you learn some of the first principles or jumpstart that process. These slides are all obviously they're online. They're on my GitHub. So all these examples are available to you. But these are some of my favorite resources. The community gallery, which I didn't open as a tab, was made by a friend of mine, Chris Fiao, and this has over 1,500 examples of D3 with screen. Most of them have screenshots. This is built in D3 and cross filter, so you can like filter out the type of visualization you want or where it comes from or who wrote it. Mike Bostock has 560 examples because the man is superhuman. And yeah, so this is a really, really good place to go to try to figure out, how to do something cool that you've seen before, or find cool inspiration or examples of how to do things, people using some of these techniques in interesting ways. Can't recommend it high enough. Mike's blog is an incredible place to learn. Like, he writes these really comprehensive, it looks like, yeah, he just posted his I/O talk, and this is going to be an epic post. I mean, he just posted this today. But he goes through a lot of the sort of, how selections work. This is like a really complex concept to grasp. And his whole talk at I/O was about how important examples are, both to create for yourself and to create for others and to learn from. And I'm glad he put it up here and wrote it out because yeah, I think everyone can benefit from checking that out. Also, the D3 homepage API reference, I think Google, if I just type D3 API, the first link is the reference. I go there so much, and you should always have this open in a tab if you're working on some D3. Unfortunately, it looks like the Wi-Fi is slowing down, but it's very easy to find, of course, by Googling. There's a set of tutorial videos by a guy named Vieno who is going through the API, basically like function by function, or maybe like group by group, and showing you like coding an example with that API function. He's got about 20 out there, and they're really nice, easy to follow. So if you're getting started, it's a great way to kind of follow along and do that. Like I said, I also make some tutorial videos. Mine are a bit more scatterbrained. I try to like find some interesting concept and try to boil it down to a quick example and share it, but it's not nearly as systematic. So I would recommend starting with his, and as you feel like it, you can browse through my videos, which I linked in the beginning of the presentation. Also, it sounded like many of you had seen Brett Victor's at least one of his talks. This is one of his more recent ones. I think he's got like 3 up on a page. Yeah, if you go here, you should watch all 3 of these and then get depressed because our tools are like 20 years away that we need. But you can also help me build Tributary because I'm trying to get here, and then we won't be depressed. So yeah, I mean, it is very inspiring talk, and it's very interesting both about tools and programming, but also data visualization and creating visual stuff. So I have been talking a bunch of stuff, trash maybe not, but let's walk the walk. Also, this presentation was made with Big, which is this pretty cool little library, very small, and D3. Yeah, actually, yeah, it's because the text is big. So let's close this. Leave this page. Looks like I have 3 of the same thing open here. Close a couple. So what I've done with a fair number of talks is okay. How can I do that? One thing I like to point out is that Google Forms are pretty sweet. You can do this thing where you can like take a spreadsheet and publish it to the web, and then I start publishing. I take this URL, and if I just go to this URL, it will be like a table, a spreadsheet. But if I go to the end of the URL and I change HTML to CSV, it downloads CSV, and I can open that up and of course use it. I'm just going to copy it, and oops, I wonder if I have to.
They don't have it available as JSON?
No, there's a lot of things actually wrong with the Google form. I want to make my own form maker, but only so many hours in a day. JSON, let's try it. No, sadly, but good thing in Tributary. So D3 does this thing where I can actually show this both ways. So one thing I can do is I can just make a file here and say, twin.csv, call it whatever I want, paste this in here. If I now, oh no, the resolution's too low. Stupid responsive design, who thinks that's a good idea? Yeah, so if I want my data, I can say, this will actually log out. So in the environment in Tributary, it takes the CSV file and parses it out into JSON using the D3 CSV function. And so here we see all of our answers to our questions as JSON objects. The same thing could be done. Let me console this log or comment this out. the way you would do this sort of without tributary and to make an AJAX request, you would give the URL here. So let's, excuse me, copy this, paste this here, CSV, pass a callback function, and then if I, what is it, data. So now I get that very same data back. So this is how you might do it, in your environment. What the problem with this in tributary is that every time I type, it's going to hit that AJAX request again, and I want to code kind of synchronously while I'm prototyping. I don't want to wait for that to happen if there's a slow connection or anything. So that's why I made this kind of way of accessing it. So usually what I do is say something like data equals 20. Oh, and I should mention that, the name of the file I put here is the name of the variable. It just kind of figures that out. It's a convention. So this is this sort of early to the earlier point about JS Fiddle. Like, I'm designing my own conventions in to just make it quicker for me to do stuff. I don't necessarily check them, and unfortunately, the UI is not designed well enough for people to not make different assumptions or mistakes. But I do have a mailing list. Try to like point people in the right direction. So hopefully it helps. So once we have data, so I had two ideas for doing a little live coding to kind of illustrate using some of these different pieces. One of them is usually to do like something with your data, but the other thing, which I kind of want to do more, is I saw this great talk at I/O this week about learning curves and how when we learn something new, whether it's an instrument or programming something or designing, there's different kinds of learning curves. And I thought it'd be fun to actually like build our own D3 learning curve drawer. So we can, within very few lines of code, build an interactive tool to make the learning curve so that we can communicate where we are stuck. Or so for me, I have my own perception of how hard it was to master different parts of the API, and there's still parts where not only have I not mastered it, but I barely touched it or even know about. So I was kind of thinking of doing that instead. So what I'll do is just save this in the gist. So when I click save, it'll make a gist out of it. This URL is available, and if you guys wanted to play with a CSV thing after this, we can do that. But what I want to do now is take this sort of fake data I prepared before and create this learning curve thing using some of the more like D3 API things. So similar to the CSV thing, if I do .json and I put some data in here, I can get it out like this. I don't know, is that big enough for you guys to see, or we'll see if this works. Yeah, it'll be kind of weird, but let's see like this. All right, so what do I have in here, right? I have a bunch of objects with a type and a value. So what I want to draw to give you kind of an idea is that I feel like over time I got familiar with a certain part of the API, and then like that raised my skill, and I was able to do stuff with that for a while, and then I learned like another piece of the API, and maybe I learned a couple of those close together, and that like raised my level a little bit. And in my mind, what I see when I think of my learning curve is like a staircase. But it's not. This is not purely data driven. It's sort of, I have my own like fuzzy scale of how that happens. So what I want to be able to do actually is have a little tool to play with my representation. So we're going to like build a visualization that's actually a tool itself. And probably I did did this before. I think we can do it in less than 100 lines of code, so it shouldn't take long. One of the first things too with tributary is you just have an SVG available to you, so you don't have to like do any markup or anything. You just start playing. And just to get stuff on the screen, what I usually do is I choose a familiar shape and like a circle, which I hope we're all familiar with, and I draw them, with the like based on the data to see something. So I'll select all the circles. Of course, there's no circles to select, so I'm going to create them. The enter method sort of signifies that. There's the opposite of enter is the exit, so you can decide what to do when you want to remove things. And I'm going to append them. So this is D3 syntax for creating an element. And then I can set attributes. I can set them as an object. You can also set them, one at a time, like this. But it's nice to do as an object. SVG circles take a CX, so like the center X position. So we'll make that a function of the data. So one thing to note, when I did this data function, maybe I should call this like types. So it's just, I'm not saying data. That's kind of hard to distinguish. I'm saying basically I want a circle for every object in my array, every element in my in this array. And so D3 is now creating a circle for each one. So I'm now going to specify what the attributes of each of those are. So to start with, let me just make the same thing for each one. So they're all going to pile up on top of each other when we set a radius, right? So here we actually have about 10 circles, but we can't see that because they're all piled on top of each other. So I have the D is the data element, which is one of these objects. So it should be each one of those. I is the index in the array. So when you make a for loop, right, it'd be like that. So I want to space them out by like 25. So I might not position them quite so far to the left. Might put them up. Might put them closer to the bottom. But maybe what I want to do is make this data driven. So I'm going to add d.value. So now each one is different, based on these values. Another thing to note though is that this first one is 62, and I added 62. It actually moved down. SVG, like most computer graphics, starts 0, 0 on the top left, and that's often not really what you want. You want things to kind of go up and to the right, if things are going up and to the right. And one of the great tools in D3 for doing that is the scales, which I've mentioned. And so you can see in there. Here I made scale sort of like the biggest, the second biggest thing, because anything data related, you're going to use these. So let's make a scale. We'll make the X scale. D3 does this a lot. To make it, you call a function that returns a function. So this gives you back something that you can then use later. It's a way of initializing things. And with a scale, you're always trying to say, I want this set of numbers to become that set of numbers, right? So the set of numbers we have are these values, and they go from about 4 to 62. They're already nicely kind of sorted, or almost sorted, but so we have some numbers that go from about 0 to 60, but we want to think about how they'll look in pixels, right? Like that's data space. Those could be like 4,000 to 6,000, right? Like who knows what your data set is. So you don't want to just be drawing whatever your data value is. You want to map it to a set of pixels, because my screen right now is only so high, right? I only have a certain amount of pixels to play in. So the domain is the set of numbers, like I happen to know it's 4 to 62. The set of numbers that are going to come in. So for each of these data points, I'm going to get a pixel value back, and that pixel value will be a range. And let's say I say that's from 0 to 200. So that's going to make, when I have a value that's 62, it's going to turn that into 200. When I have a value that's 4, it's going to turn that into 0. And anything in between, it will do a linear interpolation. So it'll be like, if I put 30, which is about halfway in between, that's going to be about 100 that comes out, right? So a scale basically saves you a lot of the calculations that you might do, and I used to do by hand every time, or just kind of double check to make sure.
And there's tools to do like the min and max and that kind of stuff.
Yeah. So I was going to show that next. So if we do the x scale, actually, this doesn't make sense for the x scale. This is actually the y scale, right? Because we're moving stuff up and down. So now I just call this y scale on this value, and you see I move things much further, like the 62 meant much further down. But I originally said this, I wanted to actually not have things go down. So you can actually just map things backwards, and now things go up, and as we change this, things scale up and down, and we can kind of get what we want. So now like our box is around this, and I can even change sort of the offset so that this is like a margin in a way. Let's keep that at 0 though. So yeah, scales, like I said, all we're doing is calling this function on some JavaScript object. So you can use that anywhere. It's really handy. There's another type of scale which we'll use for the x scale. It's called an ordinal scale, and so that's for things that are in order. So if our domain in this case is just all of our list of elements are like all these circles are in a certain order, and we just want to space them out equally. What you see here is what I did was like I started them at some point and I just like added more to each one. So I'm spacing them out based on this number, but that is not the same thing as choosing the width that I want them to fit in and having it figure it out. Like this scale will do that for us. So all we do is we pass, like I'm going to pass this just like the numbers from 0 to the length of the thing. So d3.range lets us do, if we say types.length, that gives us back an array that goes from 0 to the length. And so now every time we call, or we need to set a range, we can use range bands. So how wide do we want this, do you think? 100 pixels. Doesn't matter. No. 300. This actually takes another parameter which we'll play with. So if I say x scale of I, and I want to kind of pull this out a little bit. So now I can play. So now I'm thinking in terms of the width of my graph or my visualization. And here I'm thinking in terms of the height. I'm no longer thinking in terms of like these calculations of spacing things out, right? Like it just does it for me. And I don't need to add this here. This margin can come from this. So this, this simplifies down when we're actually doing the data stuff quite nicely. This parameter is more for like bar charts. It's to how much white space to put between each thing, and so it goes from 0 to 1. Just leave it at half. It's more obvious when we do bar charts, but I don't want to do a bar chart right now. Sorry. What I do want to do though is kind of show how quickly we can start adding some more information and playing around. So I'm gonna add some text. So SVG has text elements. They kind of suck. They're not. They don't do like word wrapping and stuff like divs. So if what you want to do is pretty simple with text, you can get by with SVG, but sometimes you got to mix the two, and there's ways of doing that. So that's so make some text. We'll set the text of that with the SVG function, or with a D3 function here, and we're gonna use the type. So this is data driven. So we created a bunch of stuff up there. But what we need to do is we want to position it next to these circles, and we want to also, well, we'll do one thing at a time. We'll position it next to the circles, and we'll see what kind of problem that causes, and then fix it. So you can set a transform attribute on any SVG element, and that kind of moves things around. Or transform will let you transform it. So the kinds of transformations are translate, move stuff around, scale, make things bigger and smaller, and rotation. So the first thing we'll do is we'll just translate, and I should be using Eric's Suite plugin. I don't think he's here right now. So what I want to do here is give it an x and y to move it to, and I want to use these same functions. So I'm just going to say x is x scale of I, y is y scale of I, and oops, d dot value. So now we have our text, but you know, it's kind of nasty and all over the place. We can play with that. We can do stuff. Also, text is like, it's 0, 0 is the bottom left. I don't know, what they were thinking there. Play around. But we can rotate it 45 degrees, or that's not nice. Play with it there. Maybe space it out a little bit. So, you know, we can start playing with that. We can set some style attributes. Oops. And maybe we'll set the font size much smaller. But the text is really here just to give us a little bit of context. I want the more fun thing I want to get to is drawing the curve, right? Like the learning curve. So let's do that. We need a path. I'm just going to straight up append a path. And really what you need to do is you need to set the D attribute, that's just an SVG thing, to a string. And like I showed you before, it's like nasty to type, and I don't want to do string concatenation to link all these together. So we're going to make a curve function, and we're going to pass it our data, and that is how we will avoid typing that out. Can you see it down there? So there's the SVG line. This is another API function. So this is part of the SVG aspect. I think I shared. Yeah, it's a fairly big square in my worldview, because it saves you so much time in making stuff. And as I alluded to before, you you define an x function, which is just d and I again, and we're just going to return x scale of I for that. And so there we actually have a path. One annoying thing though is by default it like fills it in. So we can use some CSS, and we'll just say, you know, our path element. This is another, SVG uses fill instead of like background. It's another quirk of where they're different. Stroke. I'm going to say stroke width. And then we can also take the circles. This is the same, right? Change the opacity a little bit. And yeah. So now we have a little curve. We have our circles, but the values here are the ones that I was using to show your tree map and kind of like lay out the land. What I want now I just want to play with this and be like, you know what? You know, I learned selections after I learned scales. Like scales were, you know, took a lot less. They became useful much quicker, and so I want to move these around. I want to change, you know, how high they were, how far apart they were. So we can use another part of the D3 API. So all the way down here is this little behaviors thing, which, you know, thinking about it, maybe that should be a much bigger number, because the behaviors are high leverage. They pack a lot of punch for the little amount of code you have to do. If I do, I'm going to define it up here. there's one called drag. So if I do d3.behavior.drag, all I do is define the onDrag event. And you know, I think jQuery might have something like this. But what's going to be cool is that this is going to be using the same data that we're using to draw everything. So I get like a dx. So it's like how much, when I click and drag something, how much my mouse moved, and in the x direction, and a dy. And what I really want to do is say, you know, if my data had an x attribute, I would say d.x plus equals dx, d.y plus equals dy. And to use that drag, I would just say on the circles, my circles, I call the drag. Oh, let me prove this to you. So if I click a circle and drag it around, right, it's doing that. So now we just need to make things move using that, hook it up to the data here. So what I'm going to do is make, this is like a little trick. I'm going to define one x function that if that's going to set d.x if it doesn't exist. Scale I. I'm going to use, so I'm going to replace the, you know how I called the x scale and the y scale in several different places all throughout my code? I want those all to be like done in one place, and then actually set data on my objects as I do it. So now instead of defining this whole thing here, I'm just going to pass it this function. And this will clean up my code even further down here. I can just do di, and this also get rid of more code. So now when I call drag, I think it still won't move things. But what will happen is I'm changing this d.x that's on everything. So once I rendered all these things, if I actually, let me do this, log out my data. I've put an x and a y attribute on everything, and I'm using that to draw my stuff, right? So let's see. Now the last trick is to take advantage of the D3 selections to when I change my data, I update everything else, right? So in the drag function, I just want to call an update function, and I can just put all this stuff in this update function. And there's kind of some magic happens here when I can use, so what would, what you might think is going to happen if I call an update function over and over as I'm dragging, right? It's going to call the update function. It's going to draw a bunch of circles, right? Because it's just going to keep drawing them. It won't. What will actually happen is nothing right now. But that's because I've put everything on the enter. So like I said before, like this tells us to make a new thing. It only makes a new thing if there's new data. So we can say, circles is this selection, and then we can circles. So we were chaining everything together, but now we're only appending a circle if there's new data, but we're going to update its attributes if there's if there's new data, or anytime the data changes, we'll update the attributes. So now as I drag around, the circle moves, but it doesn't create new circles. So I can do a similar thing for this. And move this around, so that moves together. So the last thing I want to do is have the path move around. So I'm just going to rewrite that with the same select all thing. I do it slightly different, which I won't get into. I can just do this, and we can move our path around. So now I can say, you know, I want to do these things. But now I can do weird stuff like this. Like, this isn't much of a learning curve. Well, you know,
learning wandering.
Yeah, maybe this is a more accurate representation of how I got to where I am. But the cool thing is you can just do a sort function, and if you return, think like this, it should like reorder them. So yeah, I put scales out in front, selections. Oh, see how I keep selecting the text? There's a really sweet CSS thing where you can do pointer events none. That works for SVG or other stuff. Same with the path. And now you can move stuff out. So layouts are pretty important. I learned that pretty early. Transitions took me a while after selections, because you kind of need to know selections. SVG stuff's cool. And maybe you decide, like, so this is another sweet thing about being data driven. It's like, well, I don't want scales to be the start of my curve. Like, the start of my curve is when I started learning, right? So I just go in here, add a new data point. And there's my started, you know. So yeah. All right. Well, I've been talking for quite a while, coding. Maybe we'll stop here, and if you have any questions, we can like chat for a little bit and do that. So yeah. So thanks for listening.